Hi everyone, in this case we have a nice exercise where we can practice our analytical implementation skills. I've got here 5 voltage as energy source. I've got 4 resistances R1, R2, R3 and 4. Each one 1 kilo ohm, 2 kilo ohm and so. As you can see below, I first have to make analytic calculation for this circuit. Next I will implement a circuit kit in Tinkercad, and finally I'll measure the current, resistances and so in our circuit. And without any more to say, let's start. Okay, as I told you before, I calculate the current in R1, R2 and R3 and R4, the equivalent current and the equivalent resistance. Here we need to calculate the equivalent resistance in this parallel circuit. Okay, here, and we can do it if we operate one. I put equivalent resistance. It's equal to 1/1 plus 1/2 plus 1/3, all with a power of -1. Okay, this circuit. The equivalent resistance here is equal to 6/11, what is equal to 0.54, what is equal to 0.55, okay, kilo ohms. Okay, next we need to calculate the equivalent resistance for the serial circuit here. Okay, and we'll do it here. And for that, very easy, just need to RE1 it's equal to plus and the R4, what is equal to 4, okay, equal to 4.55 kilo ohm, of course. Now we have the two equivalent resistances here and here, and here, what is equal 0.55 and 4.55. Okay, now we can obtain the main current. Of course, we need to use the Ohm law, VIR. Okay. We know the voltage with equal to 5 volts. The current is our incognite. So here times resistance. Our resistance is equal to 4.55. So the main current is equal to 1.099 amps. Okay. Kilo. We're working with kilos. Okay. Okay. And now you know the main current it's in here RE1, what is equal to RE0 to R4. Okay, so in R4 the current is equal to 1.099 kilo ohms. Okay, kilo ohms. Okay, it's not equal, it's just in R4. Okay, in R4 we have our first calculation here. To calculate the values in
R4, R3, R2, R1. Okay, and now we have to calculate the R1 over R2. We need to operate again with beer, but in this case, I can use him. BIR. In this case, we don't know what is the voltage, so we know that we have the current, what is equal to 1.099 times, and our resistance, what is equal to 0.55. Okay, you know, here we are using here, and that it's equal to 0.60445. Okay, and with that we can calculate I1, I2, and I3. Okay, I1, I2, and I3. I1 will be equal to 0.060445 over 1, 0.60445 over 2, and 0.60445 over 3. Okay, and the first one, of course, is the same. Kilo ohms. The next one will be 0.30225, maybe. Let's approximate. The next one, 0.201484 kilo ohms. Okay, done. I've got I1, I2, I3, I4, the main resistance, the main current, and let's continue. That's the end of part 1. Of course, I1 is here, I2 is 3 here, I3, and I4. Okay, don't forget it. Just let's continue.
Hi again. Here we need a Tinkercad free account. You can do it alone. After that, click on circuits and create a new one. Circuits and create a new one. Okay. Just wait. Here we need a testing board. What is here? After that, we need 4 resistances. Okay, 1, 2, 3, and 4. Okay, and Arduino board. Arduino here. Okay, right here. Just wait a second. Okay, done. In this case, I'm gonna use the testing board horizontally, so the energy source needs a direct contact with the parallel circuit. I place R1, R2, R3 in parallel. So, of course, first we need to set the respective value to each resistance. So 1 kilo ohm. Here's 2. Here 3, and you 4. Let me check it out again. 2, 3, and 4. Okay, this and done. So 1, 2, and 3. We need to put it horizontally like this. Just click here. 3 and 3. R1 here. I'm gonna put it where maybe we can use here. Yes. R2 and R3. Okay, here. Of course, we need to create a parallel circuit like this. I'm gonna use the color gray. Okay, you also. we need our better like this to see what we're doing. So we need a direct contact with a parallel circuit here, okay, right here with R1, R2, R3. So I need I wanna extend here to here, next I'm gonna put here, I wanna set the color red. Okay, we need this part, we have this part, this connection to this parallel circuit, and now we need to a direct contact with the parallel circuit with a resistance fault. So I'll place R1 here. You can be here, okay. We need more space, I think. I'm gonna put this here, okay. Well, it's enough here. I can do it here and you here, and I create a direct connection to the parallel circuit here, okay. I'm gonna change the color again. Of course we need our output in the ground wire, okay. So you here to here, and you to the black wire, UV wire. This is the ground wire, okay. I think that's it. Let's make a measure of the main resistance, okay. For that we need to a multimeter here, okay. Multimeter. Okay, you are here. I wanna change the voltage mode resistance, okay. Red here and the black here. I wanna move it here. I wanna start the simulation, okay. Okay, as we expected, we have the main resistance of 4.55 kilo ohms. If you remember the first part in our analytic calculations, we've got the same, okay. Okay, I got here, if you can see, okay, right here 4.55 for the error for the main resistance, okay, kilo ohms, okay, of course. Now I can stop the simulation. I can delete this and delete that, and we can 5V here and GND here, okay. And of course this is red and this black. I can start the simulation again. All is working well. It looks well, but everything looks well, okay. And that's the end of the part 2. Okay, this is the last part in part 3. Now in this part we need to modify our circuit a little, but necessary to measure each core in each resistance, okay. First we need to add some multimeters, so it's not necessary, actually 4 is enough. Make sure you have the resistance mode, okay, resistance, and U2. Now we have to modify something. I'll change the position of R1 to here, and I will use this multimeter to extend the connection from here to maybe can be here. The idea is to obtain more space, okay. I wanna change the color, maybe I don't know, yellow, okay, yellow too. Now of course we need to fix our circuits here. I wanna extend here our R2 again. You have to change the position here. I'm gonna use the second multimeter from here to here to the main point, to the original point, of course. I'm gonna use the color yellow again. Okay, it's yellow. And R3 I'm gonna place here. I wanna extend the connection here. This gray, and of course I use this multimeter to extend the connection to the original point. Okay, like this. Okay, I'm gonna use the color yellow again. Don't forget our R4. I will add a multimeter, maybe from here to here. Okay, to extend the connection. Hopefully it's working well, everything. Let me check again. This connection is here to here. Okay, this connection is here to here. I can use it. I can go here. Okay. This connection is from here, and you here from here. Okay, Arduino is connected. What we have to do now is just start the simulation. Okay. Oh well, we don't know. We don't know the. We don't need the resistance. We need the amps. Okay. Amps, and amps. Okay. Let's check how it's working. Okay, something wrong. We don't have the same values as we calculated, so something is wrong in our circuit. Okay. First of all, as you can see, we have minus 300 and minus 200, and this is incorrect. We need positive. The current is in opposite way. Okay, you have to modify it to here. Okay, why not put it here, you here, oh, the same for you here, and you here. Okay, let's check again. Okay, positive. And now this point this line is incorrect. We need to modify it here and here. Okay, let's start again. Let's check again. The same. Black here. Okay, it's a little difficult to. Here, you here. Oh no. Okay, and you here. Yes, I'm changing the current way. Okay. Let's start again. Yep, it's okay. We got 1.1 amps, 300 amps, 300 amps, 2 micro. Okay, microamps, and milliamps. Okay, and as you know, let's go. As you know, I1 is equal to 0.6044. Okay, kiloamps. Okay, what is equal to 600 microns. Okay, one I2 it's where I2 is here. Okay, here 300 microns, what is equal to 0.3025 kiloohms. Okay, I3 it's equal to 200 microohms, what is equal to 0.2014 kiloohms. Okay, finally where are you? Okay, where are you? You are here. Okay, R4 what is equal to 1.099 kiloohms, what is equal to 1.10 milliamps. Okay, so actually here I think it's not kilo, it's just milli. Okay, just fix it, but milliamps. Okay, milliamps here also, and milliamps. Okay, milliamps, but the values in general are equal. Okay, the calculation is alright. So that's it. I hope you enjoy, and I see you in the next time.